This is the story of before the beginning of the ideas that dared to stare into the moment when time itself was born. At first glance, the question seems simple. If the Big Bang happened 18 billion years ago, surely there must have been a before, right? But this is where our everyday intuitions collapse, because according to general relativity, time and space are not separate. They are part of a unified wall, space-time. And the Big Bang wasn't just an explosion in space. It was the expansion of space itself and of time. In other words, time began with the Big Bang. So asking what came before is a bit like asking what's north of the North Pole. But physicists are not easily deterred. In Newton's universe, time was absolute. It ticked steadily forward like a cosmic clock, unbothered by the events within it. But Einstein stuttered that view with general relativity. He showed that time bends, stretches, and warps depending on speed and gravity. And crucially, that time could begin and end, depending on the shape of the universe. Still, general relativity can't quite tell us what happens at the very first moment. The equations blow up, the math gives us infinity. That's a red flag. It's the universe telling us, you've asked a question I can't answer. And so we turn to the world of the very small. Enter quantum mechanics, the laws that govern particles and waves at the tiniest scales. When we treat to apply both quantum mechanics and general relativity to the first instant of the universe, we enter a realm of quantum gravity, a frontier we're only beginning to explore. One idea to emerge from this meringue is the quantum fluctuation model. Imagine a sea of bubbling nothingness, a quantum vacuum, empty yet full of potential. In this view, our universe may have been born from a spontaneous fluctuation in this quantum fountain, a bubble that inflated, expanded, and became everything. In this case, there was no before in the usual sense. Just an eternal quantum backdrop, seething with energy, occasionally spitting out universes. Ours just happened to survive. But perhaps the most mind-bending idea comes from a man who helped rewrite physics in the 20th century, Stephen Hawking. With physicist James Hartle, Hawking proposed the secondary condition. In this model, the universe is finite but has no edge, no boundary. Much like Earth's surface, which is round and continuous, with no special point that marks the beginning. The Big Bang, in this view, is more like the South Pole, a place where directions blur together. Before it, there is no before, just a smooth, rounded beginning where time morphs into space. The question of before the Big Bang becomes meaningless, like asking what's before Monday in a calendar that begins on Monday. And yet, there are other possibilities. Some theories suggest we're just one bubble in a multiverse, an infinite cosmic fountain of universes, each with its own beginning, laws, and fate. In this picture, our Big Bang was a local event, a kind of collision or birth within a larger structure. Before our time, there were other times. Made even other Big Bangs. One idea called Catholic cosmology imagines a universe that expands, contracts, and is reborn again forever. In this model, before our Big Bang was another universe, perhaps very different, that collapsed and bounced into ours. If this is true, then the Big Bang wasn't the beginning. It was just a beginning. But here's the haunting truth: we don't yet know. And maybe we never will. Because the earliest moments of the universe are shrouded behind a veil we cannot yet pierce. Core physics breaks down at the singularity. Our tools, no matter how sophisticated, run into a wall of uncertainty. And yet humanity keeps looking. We build better telescopes. We are new models. We scan the cosmic microwave background for faint clues. We dream of a unified theory, one that will merge quantum mechanics and relativity, finally letting us see beyond the curtain of time. For now, the origin of time remains a mystery perched at the edge of science and philosophy, fact and imagination. But maybe that's part of what makes it beautiful. Because in trying to understand the beginning, we come to appreciate the present. We may never know what came before time, but we know that now, in this moment, we have the power to wonder. And in a universe born from mystery that might be the most common thing of all. If you enjoyed this journey through cosmic origins, like and subscribe for more. This is history of the universe where the past isn't just began as it's written in the stars. It begins with a question that has haunted humanity since we first looked up at the stars. What came before the Big Bang? Was there a yesterday before time? Or was the beginning of the universe truly the beginning of everything? For centuries, we've cast this riddle across myths, theories, cupboards, and satellites. And now, with the tools of modern physics, we are closer than ever to perhaps relating we may never know.